Hello, future RMTs. Welcome to the discussion of laboratory automation. In the previous topics that we have discussed, those are the topics or content about the analytical techniques which can be still useful in the function or in the clinical laboratory nowadays. Remember that analytical techniques serves as our foundation for our laboratory automation because some or most, if I may say, of the laboratory techniques that are still used nowadays are based on the principles of our analytical techniques. This time, instead of discussing the conventional techniques, which is your analytical techniques, this time, what we are going to discuss is all about the applications of our laboratory test of our analytical techniques in order for us to have a fast, accurate, and more reliable laboratory results. To start with, the very function or purpose of our or the goal, the goal of automation in the clinical laboratory, most especially in the clinical chemistry section, is actually to produce accurate and precise, reliable results. Produce accurate because you are going to control, okay? You're going to standardize, okay? Laboratory testing or laboratory analysis. What else? Precise. The measurement, meron lang siyang minimum or minimal error or minimal margin, no? If we are going to repeat the test, most especially if the testing or the sample that we are going to use does not have high amounts of our analysis. Why accurate and precise? Because the conventional one or the manual method, okay, the manual method is prone in error. Take note of that. The manual method is prone in error because of what? Because of the technicalities. Okay? Because of the human error. Okay? Medtech error. While our machine, our automated chemistry analyzers will give you a more accurate and precise. However, there's a word however, we must make sure or we must ensure that our machine is within control. Within the control is within the positive or negative 2SD so that we can say that there is no a problem in our machine. There is no systematic error, there is no random error, and there should be no violation in the Levy-Jennings chart. Remember guys, remember our control values should fall under or between positive, negative 2SD only. Okay? So that we can say that our test results are accurate and precise. Now, moving forward, there are three phases of laboratory testing, which I am very much sure and aware that all of you are knowledgeable about this. We have your pre-analytical phase, we have your analytical phase, and we have your post-analytical phase. Between these three, your pre-analytical phase is one of the most crucial part. Why? Bakit siya yung crucial? Hindi naman siya yung testing. Pre-analytical stage is crucial because this is the time wherein you are going to identify the patient. If you fail to identify the patient properly, if you fail to prepare your patient properly, if you fail to do both, it will affect your analytical, it will affect greatly your post-analytical phase. If you were not able to collect sample correctly, it can also cause problem in the analytical phase. Okay? That's why between these three, si pre-analytical phase, yun talagang pinaka-crucial. Well, the heart of analysis is your analytical phase. This is your chemical analysis. This is your chemical analysis. In chemical analysis, this is the time wherein your laboratory analyzer or your automated analyzer will do the testing. And lastly, The post-analytic phase wherein you are going to have your data, the results. Okay? Wherein you will have your results. Okay? So again, in pre-analytical testing or pre-analytical phase, it includes your sample processing, your centrifugation, no? Your centrifugation, and your loading. Pag po sinabi nating loading, loading in the machine or loading in the equipment. Now, once we said automation, when we said automation, it implies mechanical or electronic control over an analytical process that the instrument performs. Okay? You will just load the sample in the machine and let the machine do the analytical processing. Let the machine do the testing, the quantification, and the quantification of the analytes to be tested. Take note that when an instrument performs automatically, an analysis requires much less operator time. You just have to you just have to feed, you just have to load, and wait until the cuvette is discarded by your analyzer, and the results will automatically flash or will automatically be available in our laboratory information system, or what we call LIS. Okay? Remember, labs seldom have an excess of staff, and the presence of these automated machines can cope with the volume and variety of tests demanded by the physicians. Kaya po yung isang purpose ng automation natin is to shorten, no, the turnaround time, because we just have to put it in the machine. We have just to load it in the machine and let the machine do it. But I am always keep on telling and saying that we must be able to correlate the results of the test kahit po yan ay galing sa machine. What do I mean? It is not necessarily mean ang galing siya sa machine that is 100% accurate. We have to check and we have to validate. That's why we have what we call delta checking, diba? When we said delta checking, we are comparing the previous results from the present result so that we can see the integrity of our testing. Okay? Hindi pwedeng mag-rely ka lang doon. Your brain, your mind, your analytical thinking must always work with your laboratory equipment, with your machine, so that you will come up with accurate and precise diagnosis. Okay? Yun nga lang, there's a seldom, or laboratory seldom have an excess staff. Medyo nababawasan yung number of staff, but you should not be threatened if laboratories nowadays are working in the under automation, because those machines will not function well without the care and the love of a medical technologist who are doing and who are performing the controlling the standardization, no, of the machine. Okay? Now, what are the rationale for automation? Number one, human performance varies over the course of time. Kapag pagod na pagod ka na, pwedeng minamadali mo na lang. Kapag masyado kang maraming ginagawa, pwedeng hindi mo na siya naiisip ng husay. Or, if you are not on focus on what you are doing, you might have a problem in dispensing the serum and dispensing the chemical that can cause a serious problem in our testing. However, machines can perform the same degree of reliability at midnight as they did in the morning or afternoon. Kasi sa gabi, medyo inaantok ka na. Di po ba? Sa umaga naman, medyo kagigising mo lang, inaantok ka na din. At saka sa hapon, no, kapag masyado ka ng maraming nagawa, pagod ka na. Yung machine, kahit po yan ay pagod, gagawin pa rin niya the same reliability and accuracy of the performance, whether sa gabi, sa umaga, or sa hapon. However, no, kahit po siya ay can do the same reliable test or same accurate test, no, we must be able to do the standardization, the controlling of our machine. Now, take note that since most laboratories work are repetitive, boredom sets and a number of errors increases. Yun yung isang dahilan ulit-ulit ka na lang, parang nagiging complacent ka na, nagiging, ay, okay, parang alam ko rin. No, it shouldn't be like that. And lastly, there's a shortage of laboratory personnel. Even nowadays, no, there is still shortage. in the laboratory personnel. Now, what are the advantages of performing automation? Well, definitely, aside from it makes our life easier, it makes the life of a medical technologist easier, no? It is capable also of increasing the number of tests. Could you imagine if you are going to use spectrophotometry or spectrophotometer and you have to run samples, no? Gagamit ka ng spectro. Tapos you have 10 FBS, 10 BUN, 10 BUA, 10 CREA, 10 COLE, 10 lipid LDL, 10 HDL, 10 triglycerides. Before you can do or before you can test BUN, you must finish first the 10 FBS. Kung paulit-ulit yan, mong gagawin, ilan po yan? 10, 20, 30, 40, 50, 60, 70, 80. 80 times kang nag-test na nag-test. But in our automation, if there is a 10 sample, no, with the same test, they can do it simultaneously without waiting for another analyte to be tested. If you will just load the sample in a machine all together and the test will be set using the barcode, no, through the help of our LIS, the machine can do it alone. Ilagay mo lang doon, let the machine do it for you, and after the machine release the results for you, then that's the time for you to make use of your brain for critical thinking and analysis of the results. Next, minimizes the variation of results from one medical technologist to another. One of the common problems here is the dispensing of reagents and your serum using your automated pipetter. Common po yan. That is an essential skill for a medical technologist, but can also be one of the reasons why there is a variation of results. Second, third, eliminate the potential error in manual analysis such as pipetting, calculation, and transcription of results. Dahil nga ikaw ay conventional one or manual method, you have to check the absorbance and you have to convert it, no, the absorbance into concentration using the Burst law if the machine follows the Burst law. E nagkamali ka ng commute, hindi mo naman nakita, yun ang resulta mo, hindi yun yung tamang result. Okay? Use small amounts of samples and reagents. Yes, no? Small amounts, kaya nga tipid. However, the reagent, mas maganda pa din if we are going to do testing by batch. Okay? Batch testing. And then, faster turnaround time. Could you imagine, no? Let's imagine that laboratory nowadays are functioning in a with the use of spectrophotometer without the use of our chemical analyzers or automated analyzers. Let's assume that an FBS, no, kasi meron ka pa siyang incubation period. Okay, may incubation period ka pa bago mo ilagtingan ang iyong absorbance. Kasi bakit? Because of the depending on the principle of the test. If that is an enzymatic one or kinetic, usually kapag enzymatic, kailangan mo siya ng incubation period. And incubation period takes time. No, it can last for more than 5 minutes. O sabihin na natin 5 minutes lang ang isang incubation period. Before you can perform, no? Dito pa lang 10 FBS na to, it will take you 50 minutes. 5 minutes times 10. Hindi pala. Yeah, 50 minutes or almost 1 hour just waiting for the incubation period per sample. Mabuti if you are going to use a spectrophotometer with incubator that can hold 10 samples at a time. Pero paano kung 1 sample at a time, then you have to wait 5 minutes. Saka mo pa lang siya iraran. Could you imagine the time that it will take if we are not going to use automation, if we are not going to embrace automation? Thus, therefore, we said that automation makes our turnaround time faster. Okay. Next, what are the approaches of automation? There are 3 approaches. Number 1, we have your continuous flow analyzer, we have your centrifugal analyzer, and we have your discrete analyzer. So what is the difference between these three? First, let's discuss what is your continuous analyzer. So when we said continuous analyzer, it requires liquid. No, liquids are being pumped through a system of a continuous tubing. Take note of this: continuous tubing, continuous flow analyzer. Fluids are pumped through a system of continuous tubing. Next, another thing that I want you to take note about continuous flow analyzer is that sample flows through a common reaction vessel. Okay? Common reaction vessel. Heating bath maintains the required temperature to allow the complete color development. Usually, our continuous flow analyzer is based on the color or the degree of color being tested. So, ibig sabihin, the more the color intensify or as the color intensifies, no, it is correlated to the concentration of the analyte to be tested. So, what are the examples of our continuous flow analyzer? We have your simultaneous multi-analyzer, and we also have your auto-technicon. Moving forward, no, we have the pump. So sabi natin kanina, si continuous flow analyzer, yung pong fluid ay meron siyang continuous tubing, no? Na pinapump po doon yung ating fluid sa continuous tubing. When we said pump, that is the one that aspirates the sample. No, the pump can be a plastic tubing or plastic tubing of varying diameters. So pwedeng maliit, malaki, depende po sa machine that you are going to use. The exam or the one of the purpose of the pump is it withdraws a large aliquot of serum from the cuvette. No, it will just aspirate a sample for testing. And take note that each sample is propelled through the tubing. Even chemical test is performed on a fraction of a sample. Now, aside from pump, we also have your dialyzer. Kapag po sinabi natin dialyzer, take note that that is the most common, no? Or this is the constituent desired. Okay? The constituent desired is separated from the test of the serum compartments or components. So yung test, no, kukuha lang po tayo ng ating itetest, no, at hindi po lahat ng serum sa cuvette yung ating itetest. That is the purpose of dialyzer. And the separated components are directly placed in the waste channel so that it will not cause a carryover in our sample. When we said carryover, yun po yung parang waste na nanggaling dun sa previous testing or sa previous analyte na ating tinest or sa previous sample na ating tinest. Or we said heating bath, well, the very purpose of heating bath is a tubing connecting the reagent and the sample passes through a water bath at a temperature needed. Okay? Since there is still no a requirement in the temperature, hindi mo na kailangan mag-incubator no sa conventional or sa manual method because our automated analyzers, for example, Auto-Technicon, is capable of performing no the incubation inside the machine. Okay? So that is our continuous flow analyzer. Oh, we also have what we call the colorimetry. Like what I've said, di ba kanina, as the color intensifies, no, the concentration, it is directly proportional, no, to the concentration of our substance. So based on the colorimeter measures the concentration of a substance. Okay? Take note, guys, that in colorimeter, that is the principle behind our continuous flow analyzer, and it is based on the reagents and sample passes through the colorimeter. Again, yung intensity ng color is correlated to the concentration of our sample. The concentration is converted into electrical signal to by our photocells. And lastly, the signal from the photocells will be registered in the computer processor so that we will be able to determine what is our results. Okay, so that is our continuous flow analyzer. Moving forward to our centrifugal analyzer, when we said centrifugal analyzer, it uses force generated by centrifugation to transfer specimen and reagent. No? To transfer specimen and reagent. Usually, our samples is placed in a separate cuvettes. No? Our liquid samples are placed in a separate cuvettes And our centrifugal analyzer uses acceleration and deceleration of the rotor to transfer the reagents and sample from one chamber to another. The purpose of transferring the reagent from one sample to another is to do the test for the sample that we have in our machine. Okay. Next is the sample and the reagents are placed in a separate chamber in a rotor when, take note ha, when centrifugal force is applied, the rotor spins that causes the two components of the flow into the reaction chamber where they can combine and form a product. Take note that the product solution then involves the cuvette portion. Again, when centrifugal force is applied, the rotor spins and causes the two components of the flow into a reaction chamber where they combine and form a product. Take note that the product moves to cuvette portion. That is our centrifugal analyzer. Okay? Another thing is that each individual cuvette in a rotor passes over a light source. The purpose of that is definitely the absorbance of the light. Okay? A beam of light shines through the cuvette. And since there is a beam of light, there will be a light absorbance. Take note guys, take note po that light absorbance is detected by phototube, yung ating mga photomultiplier, and resulting signal is registered and stored in a computer as the readout device. So parang yung ating spectro lang. There's a beam of light na ma-absorb ng ating sample inside the machine. Yung photo tube will detect the light absorbance and convert it into a values that can be seen in our readout device. So that's actually the same principle of the spectrum. Okay, so parang ganun. Okay, ito yung cuvette, no? Ito yung cuvette. Pagkakameron ng optical transparent, meron siyang optical transparent window, no? Meron tayo ditong light source, yung monochromator i-disperse po yung ating light, no? Papunta po dito sa ating sample so that the sample, no, will have the light absorbance and our detector will convert the absorbance into a value that will give us the result. So that is your centrifugal analyzer. So paikot po yan, no? Paikot. Kasi nga may rotor spin, no? The blue, the yellow, and the green. Okay, so this is the blue one, okay, the yellow, and the green. So, umiikot po siya. Okay? Kapag umikot na po itong ating sample, yung cuvette natin, no? Ito yung next sample naman to be tested. Next in line is we have your discrete analyzer. When we said discrete analyzer, as compared to continuous flow and to your, what you call this? Discrete is your most popular and versatile analyzer. Why? Bakit po siya yung popular? Mas marami siyang functionalities eh. Okay? Mas marami siyang functionalities and capable of multiple testing. Multiple testing at the same time. Multiple testing of one sample at the same time. Yung isa kasi, yung mga nauna kasi, capable of multiple testing, pero one analyte per sample. This time, not in discrete analyzer, kaya na yung isang sample lahat ng analyte itetest niya. It employs a variety of syringe and pipettes to aspirate and dispense samples and reagents. It only requires 2 to 6 UL of sample. Eh sir, yung palang mga chemistry analyzers natin requires only small amounts of sample. Why do we have to collect a 3 ml of serum, 3 ml of blood? The purpose of that is definitely if we have to rerun the test, we still have other tests, the same blood that we extracted at the same time from the same patient. Okay? Another thing is that each sample reagent mixture handled separately into a reaction vessel. And take note, guys, that discrete analyzer have a random access capability that allows stat samples to be easily accessed. Okay, and lastly, no, instrument repeatedly pipette small aliquots of serum into a reaction chamber where only a single test is performed. Take note, guys, that examples of discrete analyzers are your Vitros, your Hitachi Beckman, and your Asta. Okay? Si Vitros po sa kanilang tatlo, siya yung gumagamit ng dry chemistry. Later, let's see what is dry chemistry or dry slide. If I or the other term, dry chemistry or dry slide. So pag po sinabi nating dry slide or technology, no, ang una pong gumamit nito ay si Eastman Kodak at Takem, now commonly referred as your Vitros Diagnostics. Again, Eastman Kodak Etachem is the former name of your Vitros Diagnostics. And Vitros is one of the machine that uses dry chemistry. Kapag po sinabi natin dry chemistry, meron lang po siyang mga chips, no? Dito po lalagay yung ating sample and then meron na po siyang reagent. Wala po siyang liquid reagent na tinatawag. Okay? So when we said dry technology, there are two things that I want you to remember. There is a spreading layer and there is a scavenger layer. Kapag po sinabi nating spreading layer, it is the point of contact with the sample, okay, or where we place the sample. And usually, this sample that we are referring is your serum. Again, when spreading layer, now this is the point of contact with the sample or where we place the sample, and this sample is what we call the serum. Now, when we said scavenger layer, this is a optional layer. Again, this is a optional layer between the spreading, and reagent layer. Okay. Take note also that our scavenger layer is this layer, no, this layer removes materials present in the sample. Okay. This removes, no, the materials present in the sample. And why scavenger layer is removing materials, no? That these materials, no, that these materials that we are referring to might cause interference with the reaction, no? Might cause interference with the reaction. Therefore, scavenger layer is a layer that removes materials present in the sample which might interfere the result. Okay? Which might interfere the result or the reaction. Now, how about the reagent layer? Kapag po sinabi nating reagent layers, definitely it contains your chemicals. No? It contains your chemicals as well as your reagents. It contains your chemicals and reagents necessary for saan? Definitely necessary for reaction or necessary for testing. Now, what do we mean by indicator layer? When we said indicator layer, it contains the dye. Okay? It contains the dye or indicator. Ano ba yung purpose nun? Para malaman natin yung reaction. It contains the dye or indicator which reacts with the product. Okay? Taking place in the reagent layer to form colored product. Yan. Ito po yung sinasabi ko sa inyo. Bakit? Ang ating dry chemistry is based on the reaction color. Okay? Photometric based on the reaction color. Okay? And lastly, when we said support layer, it is found on the bottom of the slide. I found at the bottom of the slide, which is composed of clear plastic. Take note, guys, that this plastic is still transparent when colored complex is measured. When colored complex is measured. To give you an idea, ganito po yan. Yan. Okay? So this is your colorimetric, no? Rate slide based on the dry cell or dry technology or dry slide technology. Again, the principle is reflectance spectrophotometry or refractometry. Again, the principle of dry slide technology is reflectance spectroscopy or refractometry. Again, ito po yung ating light. Ito po yung ating spreading layer where the sample is distributed. This is our scavenger layer that filters the materials that can cause interference. This is the reagent where our sample will meet the reagent and the indicator will give us the reaction of our spectral analysis. And the support layer, there is a transparent line, no, there is a transparent line that no allows us to do the optical reading. Okay? Remember, guys, the light of the selected wavelength shines through the bottom of the cell. The light of the selected wavelength shines through the color of the cell. Number two, tandaan din po natin that the light beam reflects off the, the light beam reflects off the underside of the spreading layer and passes through the reagent and indicator layer. Again, the light beam reflects under the side of the spreading layer, okay, reflects under the side, no, of our spreading layer and passes through back the indicator, no, through back our reagent layers. So the line passes through our spreading layer back to the reagent layer and indicator layer. The next thing that will happen is that the reflected light, no, itong light beam na ito na nag-reflect, will then reach the photodetector and will end up with the computer processor for the results of our analysis. Again, the spreading layer will remove the interferences. The spreading layer is where the sample will place. The scavenger layer is where interferences will be removed. The reagent layer contains the reagent or chemicals that we are going to use. The indicator, no, is where the sample collects, no, the spectral analysis. The support, no, will layer is the optical interference for optical interference. The beam of light will pass through our scavenger layer back to the reagent layer and indicator layer, going to our photodetector, and this photodetector will transmit the sample in our readout device for our result, so that we will be having a immediate result. Okay? Now, the principle of automation again, automated instruments use robotics and fluidics to replicate manual tasks. But, tatlong but po yun, ha? Huwag po kayong matatakot na darating yung araw, mawawalan po kayo ng trabaho. Kasi I will never. Hindi po yun mangyayari. Machines will not work without the care of medical technologies. But even though that there are machines that will help our work easier and faster, we must be able to be equipped with enough critical and analytical thinking skills so that we will be able to produce an accurate, reliable, precise laboratory results for the diagnosis, for the treatment and management of the condition of our patient. Remember, before the doctor decides, you first have the supreme authority to decide whether you are going to release the result or whether you are going to repeat the test because there is a questionable result in the analysis. Now, what are the steps in analysis or automated analysis? Number one, we are almost done. Sample identification, determination of the test to be performed, reagent system and delivery, no? Uh, specimen measurement and delivery, chemical reaction phase, measuring phase, signal processing and data handling, sending of results and LIS. O, puntahan po natin ito para po mas madali natin siyang maintindihan. Number one, sample identification. When we said sample identification and determination of the test to be performed, that is under identification and preparation, that is under what we call pre-analytical phase. Ano po yung meron dito? Pag sinabi nating sample identification, that is usually done by reading the barcode. Since there is an automated one, most especially in the discrete analyzers, no, yung sample mo, you don't have to click and click all over and all over again in the screen of the machine just to load the test you have to perform. Because through the use of the barcode that we have in our learning, in our laboratory information system, it will make our work easy. Nandun na sa barcode na yon. That's why before you put the barcode in the test tube or in the cuvette, make sure that that sample is intended or that barcode is intended for that sample. Kasi kung nagkabaliktad ka ng barcode, no, yung barcode A dapat ay kay barcode B mo napunta, ay di yung test ng barcode A magagawa kay sample B. Mali na po yun. Okay? Determine the test to be performed. The LIS communicates the analyzer which the test have been ordered based doon sa ating barcode. When we said chemical reaction, this is the time that we are doing your analytical phase. Reagent systems and delivery, one or more reagent can be dispensed into the reaction vessel or reaction cuvette. Specimen measurement and delivery, a small aliquot of the sample is introduced in the reaction cuvette. Chemical reaction phase, no? A sample and reagent is mixed and then incubated for the analysis. Data collection and analysis, the measurement phase, which includes your optical readings, may be initiated before and after reagents have been added. Signal processing or data handling, the analyte concentration is estimated from a calibration curve that is stored in the analyzer. The purpose of having your quality control is so that there will be a calibrated curve for our analysis in our machine and send results to the LIS for your analysis and for the releasing of the results. Okay? So for specimen handling, we have your level sensing probes that detects the plasma or the serum to be tested. The barcode system is used for reading device for sample and reagent identification. And manual entry, pag po sinabi nating manual entry, pag po sinabi nating manual entry, edi mano-mano mong i-encode para pong nagta-type ka lang ng test sa cellphone mo. Halimbawa, you are going to click your settings, no? And then from that settings, there are tests available. I-click mo lang yun. Manual testing po ang tawag doon without the use of barcoding. Pwede po yun, it could be, but through the help of barcoding instead of doing manual testing because manual entry can also cause interference. Para kasi ang mangyayari doon is that, okay, sige, parang ganito yung mangyayari doon. Input mo, okay, pagka-input mo, pangalan ng patient, ano yung mga test? Click mo yung mga test. Okay, pwedeng mangyari, mali yung kulang yung test na na-input mo or sobra yung test na na-input mo. That's what we call manual entry. Okay, so when we said reagents, there are dry reagents, like what I've said, commonly in a lyophilized powder or tablet form that we have to reconstitute using your distilled water. For dry reagents, such as your vitros, meron po tayong mga dry slides na tinatawag. And liquid reagents na pipetted by the instrument and mixed with the sample. Yung pong ating dry slide, yung ating sample pumapatak sa dry slide, meron po yung mga layers and that layers will give us the analysis through the reaction of the light beam and the absorbance of the light beam. Okay? When we said testing phase, to the mixing of the sample and the reagent occurs in the vessel or cuvette. Pwedeng sa slide, that can be referred to your vessel, or pwedeng sa cuvette. Reaction temperature is usually, there is a variation. Okay, commonly at 37 degree. Bakit? Because of the body temperature. Lastly, we have your testing phase and we have your kinetic phase. Kapag po sinabi natin kinetic phase, this is the determination, okay, determination of sample concentration is based on change in absorbance over time. Again, when we said kinetic assay, no, this is a principle, no? Kinetic assay determination of sample concentration is based on the change in absorbance over time. Kapag po sinabi nating endpoint or colorimetric, stationary. Kapag sinabi nating endpoint or colorimetric, and there is what we call incubated at specific time or specified time, then absorbance is determined. In kinetic, meron pang change in the absorbance over time. In endpoint and colorimetric, stationary, and there is an incubated to specific time, and then the absorbance is then determined. Now, kapag po sinabi nating detector, no, detector is the system for the measurement, no, is built in within the system. Data management, ito yung computer, ito yung software na ginagamit po natin. Remember guys that laboratory results can be seen in the monitor and can also be transcribed and connected to the printer of our computer where we can automatically print our results. Okay? So again, when we said carry over, that is the transport of the quantity of an analyte or reagent from one reaction to another that can cause contamination in the subsequent one in the next test to be done. Remember also that the contamination of our sample by previous aspirated sample. And this is avoided because it can cause interference. No? This is avoided by internal or external rinsing stations or the use of disposable pipette tips of our analyzers. Okay, so we have your throughputs, your turnaround, and your pneumatic tube system. Kapag po sinabi natin throughput, this is the maximum number of tests generated per hour. Max number of tests generated per hour. Kapag po sinabi natin turnaround, amount of time to generate one results or one result. Pneumatic tube system transports specimen quickly from one location to another. Again, kapag po sinabi nating throughput, the maximum number of tests generated per hour, and it's a turnaround amount of time to generate one result, and we said pneumatic tube system transport specimens quickly from one location to another. Okay? Pag sinabi nating barcoding, this is mechanism of patient or sample as well as reagent identification. And sino po nag-identify? The one who identify is your instrument, your machine. And when we said dead volume, amount of serum that cannot be aspirated. Okay? Another terms that we have here is your batch testing. Kapag po sinabi nating batch testings, all tests or all samples are loaded at the same time and a single test is conducted on each time. Kapag po sinabi nating parallel testing, more than one test is analyzed concurrently on one sample. Kumbaga, ito pong batch testing, kung may 10 kang sample at lahat ng 10 sample na yon ay may BUN, yung BUN po muna ang itetest sa lahat ng sample na yon. Yung parallel testing, kung mayroon po tayong sample test or 10 test or 10 sample, no, at each sample ay mayroong BUN, CREA, or mayroong FBS, BUN, CREA, kaya na pong gawin yon at the same time for a single sample. And when we said sequential testing, multiple tests analyzed one after another on a given specimen. Okay? One or more test is analyzed concurrently on one sample. Yun po ay kay parallel testing. Kaya na pong i-test lahat sa isang sample. Kapag kay sequential po, kaya na pong i-test ang lahat, okay, sa lahat ng ating sample. When we said reflex testing, use of primary test, okay, use of preliminary test results to determine if additional tests should be ordered or canceled on a particular specimen. Pag naman po sinabi natin random access testing, ito po it allows, no? Kagaya ng sinabi ko sa inyo kanina sa discrete, it allows stat samples to be added to the run ahead of other specimen. Aside from that, any test can be performed on a sample in any given sequence. And lastly, we have your total laboratory automation, no? Automated systems where samples are received, centrifuged, and distributed for a particular instrument. Sa Pilipinas, I am not sure if there are automated system already. That is most probably in other countries. After centrifugation or after you receive the sample, you just load it in the machine, para siya malaki siyang room wherein yung sample mo may conveyor, no, from receiving to centrifugation, from centrifugation to analysis, and from analysis to result. Yun. That is your total laboratory automation. Uses conveyor system. And lastly, no, it required lab where volume of testing is high. Kung sobrang taas niyan, reference laboratory siya, it'd be much better if there is a total laboratory automation. But as per Philippines, I haven't encountered yet a hospital or laboratory which has a total laboratory automation. Okay, so that's the end of our discussion about laboratory automation in the clinical chemistry section. I hope you learn and I hope you learn about our topic. Thank you very much and stay safe, future RMDs.